What's up, guys? I'm David Wong, and I'm going to talk about zkApps today. I have this tutorial in front of me from the Mina protocol page. It's a Hello World tutorial, and so I'm gonna go through this tutorial. I'll learn how this works as I go, and you can learn that with me. And I believe this tutorial pretty much goes through creating your first zkApp and then deploying it and then playing with it. So let's see how far we can go. To create a zkApp, you actually have to set up the zkApp CLI. It takes a bit of time to install it depending on your connection. So I've done that prior to this video. I just wrote npm install global zkApp CLI and it just installed it. And then you can confirm the version, I guess, here. Do I have the right version? I do. And then I'm supposed to create a new project by writing zk project and whatever is the name of my project, which I've done because it also takes a bit of time because it initializes a bunch of dependencies. So you don't have to wait for me. I've done it. You can see it here, right here. Hopefully this is big enough. And I'm just going to cd into that directory and exa is nicer, huh? And we can see a bunch of files that it created. And I believe the first thing they want me to do is to delete a bunch of these files. So I'm not gonna do that. I just want to see what's in there. So let's open that in VS Code. And okay, I got a bunch of stuff, node modules, the usual npm folder for dependencies. I'm not a JavaScript or TypeScript expert, by the way, so that might be a bit I might say some funky stuff, but we'll see. And the usual, I guess, package.json that gives you scripts that you can run to like do different things. So I'll see what they tell me to run, but what I wanted to check was this add. Okay, so that's like some boilerplate example that you can use. But I guess we're gonna delete that. We're gonna delete the tests, which looks interesting as well. And interact, which I guess is to interact with whatever you deploy. I'm guessing, if I guess correctly. Well, anyway, we'll learn all of these things. So okay, I'll delete this. Interact, yeah. I'll delete add tests. Screw all of these files that we don't care about. And now, okay, I will generate new files. zk file src square. What is that going to do? Okay, so it generated two different files, a square.ts for TypeScript, it's empty, right? And a test file to test it. I think this is just the testing framework, but I'm not sure. And I'm going to create something manually. Okay, main.ts, why not? So I have it here. Okay, we'll use main as a script to interact with the smart contract. So it's not called interact, it's called main now. Let's open index.ts. Okay, we haven't seen that. Oh, okay, so it imports the wrong stuff. And now we're importing square, right? We got a .ts. .js? It is a TS file, right? Isn't it? I'm getting some error. Well, okay. Square.js is not a module. I'm guessing the tutorial has a bug that probably should fix and that this will work. No? Oh, all right. Well, let's hopefully this will work. I don't know. This file contains all exports. Okay, what did you contain before? Add.js, right? Let's see. Maybe, just maybe it's because there's nothing in square. And Yeah, maybe we need to export that for it to work. So let's start with that. And oh, I need to copy these imports, I guess. Oh, and now index ts works. Okay, okay, that was the. I told you I'm not very good with JavaScript, so we'll see where it goes. But okay, let's backtrack a bit and let's run that command again. It seems to work. Node build src main.js. Okay, these things seems to work. I don't know what they're doing. I'm just compiling things, I guess, and maybe like trying to see if I can run it. The first line creates JavaScript code in the build directory, and the second line runs it. Okay, so he created this file called main.js that doesn't contain anything because we don't do anything. Right? Okay, let's copy that. Maybe that will be useful. So what I've done, in a fast forward way, is that by the way, I don't have something to prettify what I'm typing. Sorry for that. Is that I copied basically what it told me to import. I'm guessing we use this library and the functions of this library to build a zkApp. And so here we're gonna need a bunch of things. So we're importing that. And we're gonna create our first class, which extends the smart contract class to create our square smart contract or zkApp. Again, a zkApp, if you don't know what it is, it's a zero knowledge smart contract. And okay, so I know that the smart contract has some states, right? When you deploy a smart contract on chain or a zkApp on chain, it's living there and there's some state there and everybody can modify the state. And the state is encoded here with this state decorator thing. It's a field type because we build zkApps based on fields and not, I guess if it was Ethereum, we would do something like U256. Or if it was a different language, we'd do like usize or int or like things like that. But in zkApps, since we're doing like these like kind of like mathematical circuits, we call this type field. That's the main type. We build everything on top of that type, and you sort of have to be aware. If you're using a field directly, you have to be aware of exactly what is a field. And it's like any other type, it's just a big number, and if you do additions, it can wrap around in this kind of thing, so you have to be careful. Okay, more importantly, I mean, as important, they tell you that a zkApp can only have 8 fields, and so you cannot have more state in your zkApp than 8 of these fields. So right now I have 1 field called num, and I can have 7 more of them. And a field is almost 32 bytes of data, almost. Okay, so now we have to add a deploy method. All right, so let's do that. Ooh, wait. Oh, of course. Okay. So now I have everything. I have a deploy method. And what it does is that it calls super deploy, so the smart contract deploy. I guess you have to do that when you override a function or a constructor, I don't know. And you also have to set some permissions. I'm going to ignore that for now, unless they go over that. Oh, and I guess so this is the code that gets executed when you deploy your zkApp. This will set the initial state of your zkApp. And here it's setting that num, see this num, it's setting the state to the value 3. Okay, so they're explaining to us what the permissions are going to be. They're going to be like whatever permissions are the default, but to edit the state of our zkApp, we'll need a proof or a signature. Okay, interesting. So I guess it's this kind of like updatable smart contract kind of thing, where here you're saying, I'm the administrator of the zkApp, so I can modify it however I want, as long as I provide a proof or a signature. I'm not sure what proof is exactly, but that's what I'm reading. Okay. And then, okay, so like any smart contract, I guess we can have methods. And so here we're adding one method. I'm sorry, I don't know why this is not formatting. It's formatted but not available. Why? Do I need to install something? Oh, all right, whatever. It works. Okay, so what's our method updates? So notice that there's a method decorator. So we're saying this zkApp has one method for now, and it's called update. It takes one argument. That argument, or really any arguments that a method takes in your zkApp, are private inputs, meaning that when you execute your zkApp by executing this function, and you modify the state of your zkApp, you're going to give a proof that you run that function correctly with the state, which is public information. Everybody can see it. It's on chain, and with the arguments to that function, which are secret to you. You're not revealing that to anybody else. So if you're creating some privacy based application, or you want to like have some secrets in your application, you can pass them as arguments to your function and not worry about it. Nobody can see them, and you're not gonna leak that information. Okay, so name update is arbitrary, whatever. And that's basically what I've been saying. Okay, I'm not gonna read this tutorial. I'm just gonna read the code here. It's usually pretty clear, so you don't really need to have a PhD in zkApps to understand what's going on. So, okay, current state is our state, right? We're getting the num field of our states. This is how you can read the state of the app. And you're making sure that it is equal to this state that you have here. And the reason you're doing that is that your function here wants to make sure that whoever is updating the zkApp here is using current state that is equal to the actual state on chain. And if they're trying to use something different, then it's not gonna work. That's what the assert equals mean here. And yeah, so these, if you want to think in terms of zk, zero-knowledge circuits, if you sort of know some of the background behind that, this will create a constraint. So this is what actually, once you compile that thing, will end up becoming something that you end up proving. Like these asserts. This is how you write your programs. You're asserting things, and if someone has wrong inputs, they're not going to be able to assert things. They're not going to be able to prove anything. So we have another one here. Square, which is the argument being passed here, must be equal to the current state multiplied by the current state. Okay, so yeah, you're squaring the current state, and you're passing the solution as argument to this function. And if it is indeed the correct value, it's indeed the square of the current state, then you can update the current state to that value. So to give you an example, if it's 2 at the beginning, actually it's 3 at the beginning, you'll have to pass 9 to this update function for it to work, and then you'll be able to update the state to 9, right? And then 9 times 9, 81, and GitHub Copilot is happy to give me the rest. Cool. So they're telling me, notice we have get and set. Yeah, okay. Get is to get the value from on chain, and set is to update it. And I guess you have to be careful here, but whenever you get a value from on chain, the prover could lie and not actually use a value that's on chain. So you always have to assert, to tell that your function that it should assert that this is the correct value that's contained in its state. Because again, this is something that you're gonna run locally when you execute that function. Okay, and they're telling us about the null. So and okay, that's a good opportunity to talk about field operations. Whenever you want to compute things using your fields and operate on fields, you have these functions like mul. There's probably another one called add. There's another one called assert equals, and you can kind of build more stuff on top of your field variables using these functions. And mul here is just a multiplication. Okay, so this is just saying things that I've told you. Interacting with our smart contracts. So, all right. Well, should I try to run it? Just make sure. Yeah. Okay. Seems like it's working. Let's go back to main. Let's close that. Let's go to main and add the following. Okay. So I'm just importing more stuff from SnarkyJS. I'm going to use the library underneath this application. And square.js. So square.js works, I guess, even though it's a .ts, whatever, JavaScript. And it's telling us what these are. Okay, cool. Is ready. Okay, I guess is ready is necessary just because it's WASM stuff, right? It's a initialization function for the library. These things happen. Shut down, a function that closes our program. Interesting. Not sure what that is. Field. So that's the type I just mentioned. Mina. Okay, to create a local Mina blockchain. I guess like a fake blockchain to play with things. Okay. So I guess we're not gonna deploy on chain. We're gonna deploy to a fake blockchain. Local fake blockchain. Private key to manipulate private keys. I guess I'll need an account. An account update, a class that generates data structure referred to as an account update that can update zkApp accounts. Okay, we'll see how we use that. Now add the following code. Okay, I'll add that. It's an async function. All right. Okay. Should I run that command again? Boom. Don't know what. I haven't read the code, but let's see. SnarkyJS loaded, shutting down. So yeah, so you have to wait for is ready, I guess, to initialize the library, and then you have to shut it down. Interesting. I'm wondering what happens if you don't, but that's outside the scope of this tutorial. Okay, local Mina local blockchain. That should be clear enough. You're instantiating a local blockchain, and then we're saying the active instance to local. I guess we can use different instances. Maybe they would be like mainnet, for mainnet, maybe. I'm not sure. And then I create local. Okay, so this is very common if you've built stuff on Ethereum or other blockchains. This is usually a pattern that you see in this kind of tooling, which is when you instantiate your fake blockchain, it comes with like 10 accounts or something like that. Actually, can I do console log local test accounts? Maybe we can see all of them like that. I'm also not used to run stuff with Node, so I don't know. Okay, it works. And yeah, right? Is it 10 accounts? Well, it's like almost, or 10. I don't know how to count. So the deployer account will be whatever is the first account. And these accounts, I think, are always the same whenever you run your program. They're always the same. So you can kind of create tests or things like that based on these things. Although I might be wrong. But okay, can I just dump the private key? I don't know if it's going to tell me objects. It's not going to look nice. Okay, and okay, 67 to 45, 16. I know this is a tangent. I'm just curious. Oh, okay, so it's actually creating different keys every time. So my bad. But it doesn't matter because when you're writing your tests, you're supposed to like, directly access this thing, and so you're not supposed to hard code any keys, or at least you don't need to hard code any keys. So that should be fine. Okay, so far so good. Now we're gonna initialize our smart contract. All right, so this comes here. Oh, so let's read. Create a public-private key pair. The public key is our address, and we will deploy, and where we will deploy to. So we use private key, the library, and we create a random private key. So here we're not going to use the deployer account. I don't know why. And then we use the toPublicKey function to obtain the public key. And I'm just going to assume you're familiar with cryptocurrency languages, lingo, and like an account is a private key and public key pair. So we have our zkApp address. I guess from an account, you have to choose what address you're going to deploy your zkApp to. And so, okay, you instantiate your contracts as Square, your constructor that you built in Square, right? Like that's our class that extends the smart contracts. And we use the zkApp address that we want to deploy to. Okay, sure, that's the pattern. And then, then that's why we use Mina.transaction to like create a transaction to send it to the network. And we have to await it because that's an asynchronous function. We send that using the deployer account, which probably has a bunch of money on it. This is the usual pattern. And I guess once the transaction is processed, maybe we're gonna do these things. Is that what's happening? Let's read. I'm not sure actually. Is that maybe that's the content of the transaction, which is to deploy. Okay, sign is deprecated, so that's interesting. And we're deploying this contract with this zkApp key. Okay, so maybe we get some explanations here because this is a bit hard to understand for me. Well, we're not gonna get an explanation. So just gonna assume that this is just interesting. Funding new accounts, deployer accounts, account update. I'm not sure. Use this method to pay the account creation fee for another account. Oh, you don't need to pass in the new account. Oh, okay. So this is what you do. To fund the new account, the zkApp, I guess you need some dough to like create a new account because of the fee that Mina requires for new accounts. And so that's why you need to the deployer account needs to give some money for deploying a zkApp. And then your deploy the zkApp is, I guess, to deploy it at some address, you need to prove that you're the owner of that address. So you need to pass the private key here. And probably you need to sign something to prove that this is, I don't know. I don't know what this is doing, so I'm not going to try to. Okay, and then we're sending the transaction. We're waiting that it gets processed. And after that, we can read the contract, I told you, right, the state of the contract is public, so we can just read it from our script here. This is not running a zkApp, and we can print it out. And I just did, and it told me state after initialization is 3, which sounds about right. That's why we say here, here. Okay, let's try to use our zkApp now. And I'm just gonna copy that. So to use it, we use the Mina transaction as well, right? We always interact with the blockchain to deploy or send money or interact with the zkApp. We always use a transaction from the deployer accounts. Although I think I could use anybody's account, right? So let's try it like that, and then I use another account just for fun. And then what do we do as part of the transaction? We want to update a contract, and with the value 9, right? This is what I said earlier. This is what we have to do. And I guess I don't know why we have to sign it. Oh, so I think, no, I understand. The permission here that we set was not to update the smart contract. It was to be able to run functions of the zkApp and have these functions update the states. So either with a signature, probably we mean that, I'm guessing it means that I, as an admin of that smart contract, can just change the state arbitrarily, or via proof, meaning that one of these functions was executed and a proof was provided. So I think this is what I'm reading. Either proof probably should read either a method was executed or a signature from the admin was passed. But I don't know. This is only me trying to guess at this point. And this sign thing is still deprecated, so maybe we should try to fix it with the message, and then we send it, and we read the num field, and we print it, and we see if it works. Okay, let's try it. Okay, it worked. Okay. And okay, let's try to do it from a different account. Let's see if I was right. Test account number 1, and I should be able to do it from any account, right? It's a public zkApp. I should be able to modify that. So let's see, and it works. And just to test my theory, what if I do something else? Permission impossible, maybe? What is impossible? Permission is impossible. But let's see. Oh, all right. And so cannot update field app state because permission for this field is impossible. Okay. And okay, let's say I only want a proof. So let's see if I was right. I can just call a method and that should work. And it doesn't work. I was wrong. Cannot update the field because permission for this field is proof, but the required authorization was not provided or is invalid. So do we provide a signature then? Is that what we provided? Oh no, using the private key of the zkApp accounts. So that is kind of weird, right? Like I shouldn't be able to do that if I have a signature only and I modified the state using, oh, but I'm signing it here. I'm signing it here. So that's what's happening. So I have a right to to do this because I'm signing it. Interesting. So if I delete this, I'm guessing it's not gonna work. Yeah, it doesn't work. So little did I know, I created a zkApp that nobody else but me can modify. But this is what the tutorial is saying, right? So, and yeah, they're telling us we can try and update the state to like something, but that's not correct. But I'm not gonna try that. I've tried enough things to show the correct updates. Okay, gonna ignore that. Let's try and fix that though. So these require signature. I'm not sure what I'm supposed to do. Require signature. Yeah, but then it doesn't take an argument. So how is it gonna know? How to sign this, right? Cannot add signature for private keys missing. So I'm not sure how I'm supposed to change that. All right, I'm gonna ignore that for now. And probably I would need to look at the doc to understand where are the docs. Is that the docs? All right, I'm not gonna do that. I'm gonna follow the tutorial. Oh, that's it though. I'm done. All right. So I guess that was it. So we learned a bunch of stuff. I've kind of failed here and there, but I'm learning as I'm failing. And we basically learn how to extend a smart contract, add fields or add state to your smart contracts, initialize it when you're deploying it, changing some of the permissions that allow you to or that dictates how you can modify that zkApp. And then we added a method called update that can read the state and update it and take even a secret value that doesn't really it's not really secret because we actually update the public state with it after, so we reveal it in the end by placing it in the public part. But we could have not done that, no? And then we also learn how to create a local instance of the Mina blockchain, and we learn how to deploy and transact, execute that zkApp through the script. So I'm gonna stop here. I think that's good enough. And maybe in a different video, I can talk about another tutorial or going through the docs or more concepts. All right. Hope you liked it.